we discuss how to find Fourier series of a function defined in an arbitrary interval, not necessarily the interval 0 to 2 pi or minus pi to pi. So we start by recalling that a Fourier series of a function which is single valued and continuous in an interval minus pi to pi is given by so recall that if f of x is a single valued function, so this is how we define the Fourier series of a function that is periodic in the interval minus pi to pi of period 2 pi. So let's call this definition 1. So the interest is now to see how we get a Fourier series formula for a function that is defined in an arbitrary interval from minus c to positive c. So this is the objective. How do you find the Fourier series of any function f of x, which is defined from minus c, c? So let's see the steps we need to follow. So the first step that we have to follow is to transform the function so that it gains a period of 2 pi so that we can use formula 1 to get its Fourier series. So we need to change So we need to change the function to the period of 2 pi so that we can apply formula 1, which gives the general Fourier series of a function defined from minus pi to pi. Now we do some small manipulations here to see how we can get a transformation that will map values of the function from this interval minus c to c to the interval minus pi to pi. So we know that from minus c to c, we have an interval of or simply the space from minus c to c is 2c units. So we'll say, so remember the function you're dealing with is defined from minus c to c. So we say if this interval of 2c is equivalent to the variable x of a function f of x, what would be the value of the interval 2 pi which is in the interval for which this arbitrary function f of x is defined in formula 1. So we cross multiply and we'll have 2 pi times x divided by 2c, which will give us pi x over c. So it means that for any given arbitrary value of x in formula 1, its corresponding value is pi x over c in this second case where the function is defined from minus c to c. So let u to be this value 2 pi x over c, which is the same thing as saying when you make x the subject, you get u times c over pi. So thus, we can use this transformation So let me call these two So we are going to make use of this transformation, which relates the x value that has period 2 pi in the first original formula 1, and this general value, which is given from the interval minus c to c. So using the variable c, the variable is u naught c. We can rewrite formula 1 as, so I use capital F, f of u would be given by a naught over 2 plus summation n from 1 to infinity an cosine of nx nu. Now the variable here is u. Plus bn sine of nu, where the values of a naught are given by 1 over pi integral from minus pi to pi of capital F of u du. An is 1 over pi integral from minus pi to pi of capital F of u times cosine of nu du, and bn is given by 1 over pi integral from minus pi to pi f of u sine of nu du. So remember here, n is from 1 to 3 up to infinity. N is from 1 to 3 up to infinity. So remember, let me call this formula 3. Formula 3 is exactly the same as formula 1. The only thing I'm doing, or what we are doing here, is to replace x for u. So remember, these variables are dummy. So 3 and 1 are the same. But now, using the transformation, given in 2, that is that u is given by pi x over c, which is the same thing as saying x is given by uc over pi. We have, so f of x is what can be written as f of uc over pi. I remember this is what I called capital F of u. So because now this is a function of u. And so we'll have f of x. Now the function defined from minus c to c will be given by a naught over 2 plus summation n from 1 to infinity an times cosine of. So remember, we have here cosine of n times u, but u itself is given by pi x over c. So we'll have n x times pi, or n pi x over c, plus bn sine of n pi x over c, where a naught will be given by 1 over c. Remember, we are moving from minus pi to, or we are moving from minus c to c to this interval post Fourier series definition of x already known. So 1 over c integral from minus c to c f of x itself multiplied by dx, and then a n will be 1 over c integral from minus c to c f of x multiplied by cosine of, now nx, but remember x in this transformation here given by this variable here. U is given by pi x over c. So I'll have n pi x over c times dx, and then bn will be given by 1 over c integral from minus c to c of f of x sine of n pi x over c times dx. So this is how we define the Fourier series for a function defined in an arbitrary interval minus c to c. So we can do an example to appreciate this. A periodic function of period 4 is defined as f of x equals to absolute value of x from minus 2 to 2. Find its Fourier series. So this is where now we are not defining the function from minus pi to pi. So we have from minus 2. So solution. So our interest, we have the function f of x is given by absolute value of x defined from minus 2 to 2. And by the way, you can sketch this this is 0, this minus 2, this is 2. Then when you know that when x, so say this is say 2, when x is minus 2, the value of the function will be absolute value of minus 2, which is 2. So we'll have some value here. When x is 2, absolute value of 2 is 2. So the graph of this function will assume this shape. So we have so we know that this arm from -2 to 0 is the graph y equals to minus x, or the line y equals to minus x. And from 0 to 2 is a graph of the function y equals to x. So f of x will be given by a naught over 2 plus summation n from 1 to infinity an cosine of n pi x over 2, or over 2, because the value of L in this case is 2. The value of C in this case is 2. Or maybe probably let's just write the full formula. Then we replace in the values. So n pi x over C plus bn sine of n pi x over C where a naught is 1 over C from minus C to C of f of x dx, and an is 1 over C integral from minus C to C f of x cosine of n pi x over C dx, and bn is 1 over C from minus C to C f of x sine of n pi x over C. This by definition for a Fourier series of a function defined from -6. Now, in our case, C is 2 and minus C is -2. So a naught would be given by 1 over C, so 1 over 2 from -2 to 2 of f of x dx, which is the same as 1 over 2 from -2 to 2 of absolute value of x dx. That's our function f of x. But remember, absolute value function has two parts. One part is minus x if you move from minus to 0, and then x if you move from 0 to 2. So we'll say this will be the same as a naught. I have integral from -2 to 0, and the function defined in that interval is given by minus x plus a half integral from 0 to 2, and 0 to 2, the function defined in that case is x. So when you integrate minus x, you get minus x squared over 2. So putting the limits from -2 to 0 plus a half into x squared over 2, 0 to 2. So we'll have a half into upper limit will be 0, lower limit will be minus 2, plus a half. Upper limit is going to be 2, because we have 2 squared 4 over 2 is 2, minus 0. So we'll have, so then remember the upper limit is 0, then lower limit is minus 2. So, but minus minus is plus, because we are going to have 0 minus minus 2 squared over 2. So there's a plus here. So this will give us a half of 2 is 1. A half of 2 is also 1. So we get 2. So A naught is 2. And then AN is 1 over 2, integral from minus 2 to 2 of absolute value of x dx, which is a half, integral from, then you multiply by cosine of n pi x over 2, because the value of c is 2, and then dx. So this will be a half, integral from minus 2 to 0 of minus x, then cosine of n pi x over 2 dx, plus a half into, now from 0 to 2. Now from 0 to 2, the function is x, cosine of n pi x over 2 dx. Now we use integration by parts to get a half into minus so when you combine all these two, it have minus 4 let's just work them quickly here. So for instance, if I want to, I can as well factor out the negative here. So I can write this one as negative a half, integral from minus 2 to 0 of x cosine of n pi x over 2 dx, plus a half, 0 to 2 of x cosine of n pi x over 2 dx. So quickly, the integral of x cosine of n pi x over 2 dx. So let u to be x, so which means du equals to dx, and let dv to be cosine of n pi x over 2 dv dx. So when you integrate, v will be 2 over n pi. Integrating a cosine function, you get a sine function. So which means the integral of u dv is uv minus integral of v du. So uv will give us x, so 2x over n pi times sine of n pi x over 2 minus v du. So v du we have, can factor out this constant 2 over n pi, and then sine of n pi x over 2 dx. But now when you integrate this sine function, you get negative cosine. So which will make this one positive, and we multiply by a factor 2 over n pi. So this will give us 2x over n pi sine of n pi x divided by 2. Now this will be plus because the integral of sine is a negative, so negative, negative, plus. So we get so 2 by 2 is 4 over n squared pi squared, and then multiplied by cosine of n pi x over 2. So from this point, you can actually just factor out a half, and you get, we'll have an is a half into x times 2 over n pi sine of n pi x divided by 2, and then minus 1 times minus 4 over n squared pi squared cosine of n pi x over 2, or in fact just write positive sign, which we have found at this point here. And then this is what we have from so I can take this as from 0 to 2, and then plus the other value will be a half into negative x 2 over n pi multiplied by sine of n pi x divided by 2 minus 1 into minus 4 over n squared pi squared, and then cosine of n pi x divided by 2, and then we apply limits from minus 2 to 0. So this will give us an equals to a half into 0 plus 4 over n squared pi squared times minus 1 power n, which is the value of cosine of cosine of n pi x over 2, and then minus 4 over n squared pi squared. Putting limits to the other value, we get plus a half into 0 minus 4 over n squared pi squared plus 4 over n squared pi squared multiplied by negative 1 power n. And when you simplify, you get a half, which is equals to half times 4 over n squared pi squared into minus 1 power n minus 1 plus minus 1 power n. I've simply factored out this term, which is common to all the terms here. So this reduces to minus 8 over n squared pi squared if n is odd, and we get 0 if n is even. Because when n is even, then this will be positive, this will be positive. So 1 minus 1, 0, minus 1 plus 1, 0. So 0 times this factor, we get 0. Now Bn for this function is 0 because the function given is even. So since f of x given by in this interval is even. So therefore, the Fourier series is f of x equals to, I remember a naught from our computation was given by 2. So a naught divided by 2 in the formula gives us 1. And only when n is odd, we have a non-zero value, but when n is even, we have 0 values. So therefore, the terms will be a naught, which is 2 divided by 2, which is 1, minus, so a factor of 8 over pi squared is common. And then we write the even terms involving cosine function only. So cos pi over 2x over 1 squared plus cos of 3 pi over 2x over 3 squared plus cos of 5 pi over 2x divided by 5 squared plus other several terms. So this is the required Fourier series of the given function.